Hi guys, so today I'm going to be doing a screencast on the electric forces and field um, worksheet number 37 because I found that one a bit hard and I finally got it. So, so let me read the problem. Use Coulomb's law to determine the magnitude and direction of the electric fields at point A and B in figure 21, due to the two positive charges. Q equals 7 microcoulombs. So let me start with charge A. Charge A. So let me just draw out. So here's Q1. It's easier if you number the charges so you can know which one is which. So I mean that Q1, and that is Q2, and then this is A right here. And the height is 5 centimeters. The width is 10, and that is 10. Using the Pythagorean theorem, you want to find the other side, hypotenuse. So this is going to be 5 squared plus 10 squared equals, and when I do that, I get 125. And so the hypotenuse is equals to square root of 125 is 11.1. 11.1 centimeters. So, and because I'm finding the height because I want to be able to find the angles of the angles. So let's try drawing the force diagram for this. This is A. So Q1 is going to repel, push it this way, while Q2 is going to try and push it that way. So the resultant vector would be upwards. So for force diagrams, we have to consider the x and y components. So the y component of, so this is Q1 pushing it that way, this is Q2 pushing it this way. So the y component of Q1, we call that Q1y, and the y component of Q2, we call that Q2y. So let me just make this a bit clearer, bring it down. This is Q2y, this is Q2, and this is Q1, and this is Q1y. So to find the angles, this angle and this angle, you have to use the Pythagorean theorem. So let's do this. So in this triangle, okay, do this. So we know that this angle has to equal this angle. And in force diagram, this is the force Q1. We're trying to find this angle. And because these two, because they're opposites, they'll be equal. So theta, we'll call that theta. So we have 11.1 here. So opposite of a hypotenuse. So sine theta. So sine theta is equals to, the opposite is 10, and the hypotenuse is 11.1. So sine theta is equal to 11.1. Then we have to find the inverse to find what theta is. And the inverse of sine theta is 64.3 degrees. So the angle here is 64.3 degrees. That also makes the angle that Q2 forms in the y direction to be 64.3 degrees, because they both carry the same magnitude. And if you look, I don't know if you can see this, but if here is theta, notice how like this is 5 and 10, and this is also 5 and 10, and this is 11.1, and that's 11.1, and so they are similar triangles. They're practically the same triangles actually. And the theta, this theta is equal to this theta, so that means that this theta right here has to also equal this theta. I don't know if that makes sense, but so we found theta. Let's draw actual force diagram with the x and the y axis in. Sorry, my hands are shaking. So we have Q1 here, and we have Q2 here, and we know that this angle right here is 64.3. This is also 64.3. Now we make a table to be neat. I like to make a table just so I can be able to keep track of what I'm doing. So x and y. So for in the x direction, the x direction, notice that this is going to equal this. The magnitude in the x direction is going to equal this side. So I'm going to draw a line across. So we know that theta is here, and we're trying to find this. So it's going to be sine 64.3 equals, opposite is the of Q1 in the x direction over Q1. So in the x direction, it's going to be f of Q1 on A, let's go A, times sine 64.3. And in this side, the side, it's going to be negative because it's on the negative side. So it's going to be negative. And since this is, so this side is going to be negative. And since this, because they are the same triangles, they're the same plane, charge, and angle, and everything. This is going to be the same but opposite. So it's going to be f of Q2 A sine 64.3. It's the opposite of that. So now in the y direction, we're going to have, so remember this is the angle. This is the angle. It's going to be adjacent over hypotenuse, because now we're trying to find the y component of that. So that's going to be, adjacent over hypotenuse is cos theta. So that's going to be f Q1 cos 64.3. And since this is also in the positive, like the magnitude in the y direction is also in positive, this is also going to be f, but now the charge of Q2 on A equals 64.3. Right, then we try using, because over here, remember it says direction of the electric field. So we know that the equation we're going to use is F equals KQ over R squared. Okay, so, and we know that F of Q, 1A, is equal to FQ2, because they're the same triangles. So that's going to be, let's just solve for F. So K, 9 times 10 to the 9th times Q1 or Q2 is 7 times 10 to the negative 6 coulombs over R squared. And over here, remember that this is R squared, and that's a hypotenuse, and we found that to be 11.1 centimeters. But we have to convert it before plugging it in. So 11.1 centimeters to meters is going to be 0.111 meters. So you have to square it, because it's R. And when you do that calculation, you're going to get and multiply, you're going to get so we get 5.1 times 10 to the 6th Newton coulombs. That's just for FQ1A. So for the x components, since FQ1A equals FQ2A, this adds up to 0. And for this, we have to solve for that. But if you notice, this is just 2 times FQ1A cosine of 64.3. So we found FQ. So now we're going to do 2 times FQ 5.1 times 10 to the 6th times cosine of 64.3, and that comes out as 1.02 times 10 to the 7 Newton coulombs. My work is a bit messy, but here it is, the whole thing. You could pause the screen if you want to see how I did it. It's kind of all over the place, I'm sorry. So yes, this is how I did 37 for charge A. The video has been quite long, and you could do the same thing for charge B. Just follow the same methods I use. Sketch first, find the hypotenuse, the missing side, find the angle, draw a force diagram, and then go from there. So yeah, I hope this helped. If you have any questions or stuff, then give me a comment. Yeah, that's pretty much it.